So continuing on the theme of ratios, in this video we'll be focusing on simplifying ratios, decimals in ratios, and writing ratios in the form of 1 to n or n to 1. Now, as mentioned in a previous video, there is a link between fractions and ratios, and just like fractions, we can simplify ratios in a very similar way to how we simplify fractions. Now, this is done by dividing the numbers in the ratio by their highest common factor. So, for example, if we're asked to simplify 18 over 20, then what I need to do is find a number that goes into both 18 and 24. Now, obviously, if you think big, you don't have to simplify as much, whereas if you think small, it may take you a while for you to get to your final answer. So for example, I noticed that both 18 and 24 are both even numbers, so I can divide both numbers by 2. So if I divide both numbers by 2, now whatever I do to the top number, I have to do to the bottom number. So here I've got 9 over 12. So then I ask myself, is there a number that goes into both 9 and 12? Well, yes, there is. I can divide both numbers by 3. And if I divide both numbers by 3, then I end up with 3 over 4. Now, can I simplify 3 over 4? No, and because as one of the key factors of fractions is that we don't write them with decimals, so that's where we stop. Otherwise, if you're allowed to write decimals in a fraction, where do you stop? Because then I could go into 1.5 over 2 and then 0.75 over 1, and I could keep going on and on forever. So you stop when you can't simplify anymore. Now, another alternative is if I thought of the highest common factor, so what's the highest common factor in both 18 and 24, then that would be 6. So if I get rid of all of this, and if I look to the highest common factor of both 18 and 24, and I recognized it was 6, and I divided both numbers by 6, then I would end up getting to the final answer of 3 over 4 a lot quicker without breaking it into steps. Now, if we move on to the ratio of 18 over 24, then we can do exactly the same. So again, I'm going to look for a number. Now, whatever I do to one number, I need to do to the other. So you can only, obviously, while you're working with dividing and multiplying. So here, if I divide both numbers by 6, because I'm thinking to myself, what number goes into both 18 and 24? So that'd be 6, so that'll be 3 to 4, and there is my final simplified ratio of 18 to 24. So let's have a look at some other examples. So here if I had 52 over 20, now again, if you can't think big, then just go small and just keep going until you can't go no more. So here we've got, if I divide, both numbers are even, so if I divide both these two numbers by 2, and you don't really have to write down what you're dividing it by, it's just a case of just for tutorial purposes. So here I've got 26 over 10. I could then get both even, so I can divide both numbers by 2 again. So I've got 13 over 5, and that is where I stop. Then moving on to question 2, again 14 over 28. So think to myself, what's the biggest number that goes into both 14 and 28? Well, that's going to be 7. So if I divide one by 7, I have to divide the other by 7. So 14 goes into 7 goes into 14 twice, and 7 goes into 28, and that will be 4 times. And then I can obviously then divide that by 2 to get 1 to 2. And there we go. Now another obviously easier route should have been is that obviously a highest common factor between these two numbers is 14. So I could have just divided both numbers by 14 and got to the same answer of 1 over 2. But it's always worth just taking that extra care, and obviously if one number sticks in your head, then that's going to be absolutely fine. So then moving on to the next one. So here we've got three numbers in our ratio, but the same thing applies. I need to find a number that appears in both, that goes into both 20, 18 and 30. So here I'm thinking of, as they're both even, I'll divide all numbers by 2. And again, whatever you do to one number, you have to do to the others. So that's going to be 10 to 9 to 15. So then I ask myself, is there a number that goes into both all three of these numbers? So 5 would go into 10 and 15, but it won't go into 9. 3 would go into 9 and 15, but it won't go into 10. So that there is my final answer. And then finally, for question 4, we've got 3 to 8. So think to yourself, what number goes to both 3 and 8? Well, there isn't. So this one cannot be simplified. Now, would you get a question where it's asking you to simplify a ratio which cannot be simplified? Yes. So try not to automatically think, oh, I must simplify it because it's asked me to simplify it. It's just testing your understanding. So if a ratio cannot be simplified, always make sure that you write down that it cannot be simplified. So let's have a look at a worded question. So it says a bag contains 4 red, 6 blue and 10 yellow counters. Write down the ratio of red to blue to yellow counters in its simplest form. So I would actually get 1 mark for writing 4 to 6 to 10. And again, I'm just making sure that I've got red to blue to yellow because I want it in this order. So I need to write the ratio in that same order. So looking at 4, 6 and 10, I notice that they're all even. So I can divide all the numbers by 2. So I've got 2 to 3 to 5. And then I ask myself, can that be, is there a number that goes into both 2, 3 and 5? No, there isn't. So that there is my final answer. Now again, just make sure, particularly care that the order in which you're writing the numbers is exactly the same order as how they want the ratio. Sometimes they do like to mix it up just to check your understanding and your reading of the question. So just take an extra couple of seconds to make sure that you have read the question carefully. So now let's move on to working with decimals in ratios. Now, in a similar way, and we already kind of previously mentioned this, so in a similar way, we don't write decimals in fractions. We also often do not write decimals unless writing in the form of 1 to n or n to 1, which will be discussed in a bit, in ratios. So if you originally have decimals in your ratio, you must multiply all the numbers by a number such that there are no decimals. So this is kind of going the opposite of simplifying ratios. Now to simplify ratios, we divided all the numbers by a certain number. This time we need to multiply the numbers to give us a whole number. So for example, it says that Elise and Omar spend £2.10 and £1.80 respectively on their school dinners. Write how much they spent as a ratio in its simplest form. So here I've got the ratio of, well, if I just use E for Elise and O for Omar, I've got £2.10 and I've got £1.80. Now I'm going to ignore the pound sign, so I'm just going to work with this. Now what I need to do is I need to multiply both these two numbers by a number so that I'm only dealing with a whole number. Now because I'm dealing with a decimal number and I've got 2 digits after the decimal point, well, you could say 1. What I'm going to do is I'm going to multiply both these numbers by 100. And so what I'll end up with is then, if I multiplied both those numbers by 100, I'd end up with 210 and 180. So now I've got whole numbers, which is a good thing, but I need to write this in its simplest form. So asking myself what number goes into both 180 and 210. So here I notice that straight away that both numbers that go into the 10 times table. So I've got 21 to 18. I can divide both numbers by 3. So I've got 7 to 6. And there is my final answer because I can't simplify that any further. So the ratio of Elise and Omar's expenditure in its simplest form is going to be 7 to 6. So let's have a look at some other examples. So again, here what I'm going to do is I'm going to multiply both these numbers. Now because this is I've got 2 numbers after the decimal point, I'm going to multiply both numbers by 100. So I'm going to multiply both numbers by 1 to the power of, well, 10 to the power of however many digits there are after the decimal point. So multiplying both numbers by 100, I get 260 rather, and 52. And then from there, what I then need to do is simplify those numbers. So again, what I'm going to do is try and find what number goes into both of those two. And it's actually 52 goes into both those numbers. So again, if I just kept dividing by 2, I end up with 130 and 26. And then I can still keep dividing by 2. Again, it's probably usually what you do if it's non-calculator. So I get 75. No, I get 65 rather. Checking my maths. So 65. End up with 13. And then from this, I can divide both numbers by 13. in which I get 5 to 1. Now the key thing to check with this is whichever is your biggest number, and depending on where it is in your ratio, so here my bigger number is first, I need to make sure that the bigger number in my final answer in the ratio is also first, so it needs to be comparable in terms of there. Now moving on to the next question. So again here I've got one number after the decimal point, so if I multiply both numbers by 10, then what I end up with is 14 to 60, and then from this I can divide both numbers by 2 because they're both even, which gives me 7 to 30. And can that be simplified any further? No, it can't, so there is my final answer. Now moving on to one where I've got three numbers, and again the same thing applies. So here I've got my longest decimal number is 2, so what I'm going to do is I'm going to multiply all three numbers by 100. So what I end up with is 0.5 times 100 gives me 50. 5 times 100 gives me 500. And 0.12 times 100 gives me 12. Now from this I can see that they're all even numbers. So if I divide all the numbers by 2, I end up with 25, 250, and 6. So then I just need to ask myself, can I divide this any further? No, I can't. So there is my final answer. Now another type of question you could get asked that's related to ratios is writing in the form of 1 to n or n to 1. Now this is probably the only example time where you are allowed to write decimals in a ratio. Now the best way to describe this is having a look at an example. So in this example it says that Ronaldo scores 24 goals in 20 games and Messi scored 28 goals in 24 games. Now part A says write both players' games to goals in as a ratio in their simplest form. So if we look at Ronaldo, so let's just write A. So I've got Ronaldo. Now it's wanting games to goals, and how it's written in the question is in the opposite order. So for Ronaldo, it's going to be 20 to 24. And I can simplify that because they're both divisible by 4. So that's going to be 5 to 6. And there it's simplest form. If I go for Messi, his is going to be, well, his games is 24, his goals is 28. So again, I'm just going to keep going until I can't go no more. So I've got 12 to 14, 6 to 7, and there is my final answer. Now the next question then says, which player has a better ratio? Now, if we look at it in sort of face value, these two ratios, that Ronaldo scores 6 goals in 5 games and Messi scores 7 goals in 6 games. Now the difference is 1, but the question is which one's better? Now one way to look at this is to try and have one common consistency. So what we're going to try and do is, and what makes this difficult to compare, is they're both playing different amounts of games. Now obviously I could divide both numbers by 2, but you can see that when I simplify it, there is no common number to try and get it as a common multiple. I could try and get the games the same, or try and get the goals the same and compare how many games they scored that amount of goals, and whichever one's less is better. But another alternative is to write their ratios in the form of 1 to n. So I want to know how many goals per game did each person or each player, should I say, score. So from this, what we're going to do is, well, Ronaldo scored 5 goals per 6 goals in every 5 games. So if I divide both numbers by 5, then what I get is 1 to 6 divided by 5, which gives me an answer of 1.2. So basically Ronaldo scores 1.2 goals per game, which I know is not possible, but it's one statistic that we then work out. Now if we do the same with Messi, so here I've got 6 to 7. So if I divide both numbers by 6, then he then plays one game, because remember it's games to goals. He then plays one game, and 7 divided by 6 gives me an answer of 1.666 recurring, and it goes up to 7. So basically, Messi scores 1.6 goals, or I should say 1.7 if we round up. So 1.7 goals per one game. So therefore, which plays better? Messi. Let's put Mess. So Messi, well, let's write it over here. So apologies for the presentation. So here, so the conclusion or the final answer would be that Messi has a better games to goals ratio. Now again, one thing that I would probably recommend that you do is quote at their goals per game. So let's just get rid of that and show you're working out on how you've actually got those values. And this is where 1 to n kind of comes into play. So in the following questions, we need to write it in so that the first number is 1. Now how you do that is whichever side is 1 is, you just divide both numbers by whatever number is where the 1 is in the ratio. So here we've got 2 and I want to convert that to a 1. So what I'm going to do is I'm going to divide both numbers by 2. So I'm going to divide both numbers by whatever side 1 is on. So 2 divided by 2 is 1 and 3 divided by 2 is 1.5. And there is my final answer. Now again, typically you shouldn't be writing with decimals, but because I want it in this form, it's allowed. So here I want to change the 5 to a 1, so I'm going to divide by 5, and whatever I divide the first number by, I need to divide the second number by. So 5 divided by 5 is 1, and 6 divided by 5 is 1.2. And here I'm going to I want to convert the 10 to a 1, so I divide by 10. So 10 divided by 10 is 1, and 7 divided by 10 is 0.7. And here I want to change the 4.5 to a 1, so I'm going to divide by 4.5. I do the same to the 3.6. I'm going to divide by 4.5, so I end up with 1, and then 3.6 divided by 4.5 gives me a final answer of 0.8. And there is my final answer. Now let's have a look if I wanted the second number as 1. Well, there I need to do the exact same, but with the opposite number. So here I want to make 5 equal to 1, so I divide that by 5. So I just divide whatever number is underlined, and you do the same to the other number as well. So 4 divided by 5 is 0.8, and that's going to be 0.8 to 1. Here I'm going to divide by 10, so I need to divide this number by 10. So it's going to be 0.8 to 1 again. Here I want the 40 to turn into a 1, so I'm going to divide both numbers by 40. Now this one I could simplify. If it was non-calculator, probably simplify it first, divide numbers by 5 and then simplify it. But again, it doesn't really matter, especially if it's on a calculator paper, which most often these questions are. So it's going to be 1 and then 15 divided by 40 gives me an answer of 0.375. And there's that one. And then finally, moving on to this one, I want to make this equal to 1. So divide by 1.3. So I divide this number by 1.3. And 6.5 divided by 1.3 is 5. And 1.3 divided by 1.3 is 1. And there is my final answer. Now I will put some practice questions along with their answers on a worksheet, and you'll be able to download that in the description below for you to practice everything that you've learnt in this video.